Let's discuss this topic. Sort. What is sort? Sort simply means irrational numbers. Numbers whose square root cannot give you a fixed value is called sort. Now, you can simply say that sort are the square root of non-perfect numbers or non-perfect squares. Now, perfect squares are those numbers whose square root give you a positive integer. Numbers like 1 is a perfect square, 4 is a perfect square, 9 a perfect square, 16, 36, and 49, and so on. This is perfect square. So the square root of each of these numbers, if you press it using your calculator, you keep getting a positive whole number. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So these are called what? Perfect square. Now, but when a number is not a perfect square and that number has square root, now you call it a sort, right? Like this thing now, you see 2. 2 is not a perfect square. So when you put the square root here, it becomes what? A sort. And if you press the calculator, you get decimal. So you get numbers. You get now. So those numbers are said to be sort, right? Now, when you come to how to understand the meaning of sort, the next thing is let's discuss simplification of sort. Simplification, that is simplification of sort. How to simplify sort? Simplification of sort simply means reducing sort to its lowest or basic form. When you bring a sort to its basic form, then you have actually simplified that sort. Now, let's take a look at these examples now. Now, something like sort 2 is already in its basic form. There's nothing you can do here, right? Now, sort 3, sort 6, now, sort 7, okay, even sort, okay, now, but these are what? These are basic form already. Even sort 10. Now, but what of sort 8? Now, you cannot, even though 8 is not a perfect square, but you can reduce this sort, you simplify it. How does that happen? Now, look up. 8 is simple as writing 4 times what? 4 times 2, right? So if you have sort 8, it's simple as writing sort 4 times 2. And note, the purpose of simplified sort is so that we get one number that will still be a perfect square, whose square root will give us a positive integer, right? Now, in this case now, you can say that sort 4 times 2 can still be what? For sort 4 times sort 2, right? Now, sort 4, which you know is 2, and sort 2 is sort 2 because it can simplify. So, you have simplified sort 8 to this now, right? Because you have to know how to simplify sort. By the time we'll be solving past question, you know how to apply it. Now, when you see number like this, 1, 2, 8, they'll ask to simplify it. Look for 2 numbers such that one must be a perfect square and the other one will be, a prime number, right? And those numbers must be what? 16 and 2. So if we times 16 and 2, you get 1, 2, 8. So if I have to simplify sort 1 to 8, it's same as writing sort 16 times 2, and that will give you square root of 16 is 4, then you write as sort 2. Then if you say a number like this, 1, 2, 5, you have to simplify this sort. Now look for two numbers. 1 must be a prime number, 2 must be a perfect square, right? And those numbers must be 25 and 5. If you multiply it, it will give you 1, 2, 5. Getting the sum of all this, you are going to have, for 25 is 5, then you write a what? So the 5. This is what we call simplification of surd. Now the next time I'm going to tell you now is in the basic form. The basic, I'll just call it the addition of surd, subtraction of surd, multiplication of surd, and division of surd. Now just like other numbers, right? Just like rational numbers, whole numbers that can be added, subtracted, divided. So also you can also apply the basic operation here under surd. So let's look at addition of surd. Now for addition of surd, there's something I told you about simplification of surd. Now you can add surd. The condition for adding surd is this. The surd to be added must have the same basic form. Take for instance now. You see, x surd 2 plus y surd 2. This surd can be added. Reason being that they have the same basic form. Surd 2. And if you are adding surd that have the same basic form, you add the coefficient. This is what we call coefficient. The number or letter before the surd is called the coefficient. So it is this one that you are going to add. If you add it, then you collect only one surd. What do I mean by that? I'm going to add x and y. I will get x plus y. Then I will collect one what? One surd 2. Now let's just use a number. If I have something like 5 surd 3, I'm using surd 3 now. Plus something like okay, surd 3 again. You're asked to add this. It's very simple. Provided they have the same basic form, they can be added. Remember, the coefficient of this one is 5, right? This one is what? Is 1. Is it because I did not write 1? It is 1. Because if I have x here, you know that x means 1x, right? So this means 1 surd 3. Then you can add the coefficient by saying 5 plus 1 is 6. Then you collect 1 surd 3, right? So, but in case, a situation where surds have different basic form, you cannot add them. Something like this. Let's say 5 surd 2 plus 3 surd 3. This surd cannot be added. You can't add it. You can't add it because they don't have the same basic form. All right, now the same thing applicable when we talk of subtraction of surd, right? So you subtract surd that have the same basic form. Something like let's say 2 surd 5 minus 3 surd 5. It can be subtracted. Now subtract the coefficient. 2 minus 3 is minus 1, right? Then pick one of the surd. And of course you know that minus 1 is sometimes writing minus, right? Minus, then you put what? Your surd. Alright, now, but if you don't have the same basic form, you cannot add them. And if you are adding or subtracting of surd, make sure that you first of all simplify the surd before you begin to subtract or add, right? Now, because if I say you add something like surd 1, 2, surd 1, 2, 8 plus surd 8. You see now, you cannot add this thing unless you have simplified it, right? And that should be 1 to 8 is simple as writing 64 times 2, right? 64 times 2, then plus, you can simplify this thing by writing 4 times 2, because 4 times 2 will give you 8. Right? Now, I told you that square root of 64 is what? Is 8. Bring it out. So I have 8, then so 2. Plus, square root of 4 is 2. Bring it out, then so the 2. At this point now, you can add them because they have the same basic form. Right? Now, let's discuss multiplication of a surd. Multiplication of a surd. Multiplication of surd. Now, I've told you that in one condition will you add surd or subtract surd, they must have the same basic form. But in this case, whether they have the same basic form or not, it doesn't matter. You can multiply. So this one does not discriminate. For instance, now if you have something like 2 surd 3 times 3 surd 2. This can be multiplied. Right? You multiply the coefficient together and also you multiply the surd. It's done that way. If you say 2 times 3 is what? Is 6, then surd. You multiply is 1. And 2 times 3 times 2 is what? Is 6. So you get what? 6 surd 6. Right? Now, if surd of the same multiply each other, now look at what will happen here. For something like let's say 4 surd 5 multiplying 2 surd 5. Like I told you, you multiply the what? The coefficient. 4 times 2, 8. Now, the same surd multiplying each other will give you the number. Now let's write now. Okay, let's write square root. Okay, 5 times 5 is what? Is 25, right? That is 8 times. Square root of 25 what? Is 5. So always note that whenever you are multiplying surd of the same number, just collect that number. If you say surd 3 times surd 3, it's just 3. So no need to waste your time. Alright, that is multiplication of surd. No, this is part 1 because part 2 will be more of a solving past question. I just want to take time to teach you so that when we enter part 2, then you understand it very well. Now let's discuss division of what? Division of surd. Division, just like any other number, have division. Division of what? Division of surd. So now, what you should understand about this. Now, always note that surd m, I'm using the letter m, all over n is always equal to surd m divided by what? Surd n. Don't forget this. Now, something like if a surd or if a fraction has the denominator as the surd, for instance, something like a 2 surd 3. Now, this is fraction, right? And the denominator is surd. Then you do what we call rationalization. You have to rationalize it. The essence of rationalizing this surd is so that the denominator will be a number and not a surd. So you are going to remove the surd from the denominator, and as such, if there is a need to divide, you can divide, right? Let's say something like something like 4 surd. Okay, 4 over surd 2, right? Let's do this one now. If you rationalize, to rationalize means to multiply the numerator by the surd given to you, which is surd 2. Then all over, you multiply the denominator by the same surd, which is also 2. I follow you now. And if you say 4 surd 2, it's simple as saying 4 surd 2. Just like that. Just write 4 surd 2. Then I have told you that when surd of the same multiply each other, what will you get? You get the number, which is 2. Before you can then divide. Right? Then 2 here. Here is what? The 2. You get what? 2 surd 2. That is division. or that is when the denominator is just one single sword. Now, look at another case like this. If you have something like this, let's say 3 all over 1 plus sword 2. No, this is division. This is fraction, right? Now, in this case, what you do is that you get the conjugate of this thing. Conjugate of this thing. Always note that the conjugate differs from the main sword or term because of the sign. So the conjugate of 1 plus sword 2 is 1 minus sword 2. What's the difference? The difference is the sign, right? Now, something like 2 minus sword 5. What's the conjugate? Just write 2 and instead of subtraction now, and then sword 5. So what we do under here is that for you to divide this type of sword, you first of all recognize its conjugate, right? And then which I have told is what? 1 minus sword 2. Then use it to multiply both numerator 1 minus sword 2, and also the same thing multiply what? Denominator. That is when you have a case like this. Look for its conjugate before you multiply the numerator and the denominator by the same conjugate. Alright, so that's what you have to know when we come to division of a sword. Now the next thing I want to discuss under this part 1 is discuss what we call radical equation. Radical what? Equation. Call it a radical equation. Now, radical equation is the equation of sword. That's the meaning. A sword having an equality sign is said to be a radical equation. Now, for instance, now something like this: 2 sword 3 x plus 4 plus x equal to 36. This sword is radical equation. Now it has equation. This is the sword, right? Now, so white or jam can give you question, right, concerning this now. Now, what I'm going to do is this. For you to solve radical equation, first of all, make the sword the subject of the formula. Now, the term inside the square root, we call it radicand. We call this one radicand. Right? Now, so what am I saying? For you to solve this equation, you first of all make this sword the subject of formula, right? And the second step to take is you take the square of both sides. The essence of taking the square of both sides so that you remove the square root, which makes it sword. Now let's just solve this in sum. Let us give you a hint how to solve this one. I said 2 sword 3x plus 4 plus x equal to what? 36. I said first to this one, make this the subject of formula. So having 2 sword 3x plus 4, right? That one must be equal to what? 36. Then plus x is going because must what? X. That is the first step to do. Whenever you see a radical equation. Now the second thing to do, you have to take the square of both sides. Take the square of both sides. Remember, this is the coefficient of this. Don't say let me divide this by this. No. Take the square root, the square of both sides. Of course, you can spell the square for both sides, right? And that should be, if it's square of this is 4, right? Then remember, the square is like this and also like this, right? But we normally use bracket like this. Meaning that 2 with square itself give you 4. Then times this, we cancel this. Remaining what now? 3x plus 4 plus 4. Then before you can use, you can expand this one. Get, and when that is done, you can solve the thing. Alright, so I think at this point we are going to call it a quit for part 1. So other part 2, you expect part 2 because part 2 we are going to apply all these things we said here in solving past questions. So we call it a quit for now.